Once upon a time, there was a sum. And not just any sum. This sum was special. This sum is extraordinary. This sum is the sum of all positive integers. Let's put it on the board. This sum is just 1 plus 2 plus 3 plus 4, and on until infinity. Now, Stegosaurus, get in here.
Yes, pterodactyl?
Now, what do you think this sum is of 1 plus 2 plus 3 on to infinity?
Well, I'd think it's infinity.
See, most people would think it's infinity. In fact, contrary to what people think, it is negative 1/12.
How?
Let's prove that. Let's begin our proof by defining two different sums. The first sum we'll label S, and that's the sum we're looking for, which is 1 plus 2 plus 3 plus 4 plus 5, so on to infinity. The next sum we'll label R is very similar, but this one is 1 minus 2 plus 3 minus 4, so on to infinity. The same thing except with alternating signs. Now, let's see what happens when we subtract them. When we subtract S minus R, we see that the 1's cancel, and then 2 minus negative 2 is 4, then the 3's cancel, then 4 minus negative 4 is 8. And we see that the sum is just 4 plus 8 plus 12 plus 16, so on to infinity. Now, if we factor out a 4 from this sum, we'll end up with S minus R equals 4, 1 plus 2 plus 3 plus 4, so on to infinity. And now, we quickly realize that this is the exact same thing as S. So we can just plug that back in and get that S minus R equals 4S. So if we now solve for S, once we solve it, we get that S equals negative 1/3 R. So the question now is R.
Hello, Velociraptor here, and I'm going to continue proving S to R 1 plus 2 plus 3 plus 4, and on until infinity is negative 1/12. As pterodactyl just proved, S equals negative 1/3 R, when R is 1 minus 2 plus 3 minus 4, and on until infinity. In order to determine R, we need a new term, V. V equals 1 minus 1 plus 1 minus 1, and so on and so forth. So if you do R minus V, you get R minus V equals 1 minus 1 is 0, negative 2 minus negative 1 is negative 1, 3 minus 1 is a positive 2. Negative 4 minus negative 1 is minus 3, and on until infinity. And what you realize is R minus V is just negative R. So if R minus V equals negative R, you can subtract R from both sides and divide it by 2, which gets R equals 1/2 V. So you plug this back into the initial equation, S equals negative 1/3 of 1/2 V. So S equals negative 1/6 V. The question is now, what is V?
Thesaurus here. So let's prove what V equals. V is still 1 minus 1 plus 1 minus 1 plus 1 and so forth and so on. So let's do 1 minus both sides and see if we can tease out any sort of numerical answer. So 1 minus V is equal to 1 minus 1 minus 1 plus 1 and so forth and so on, just like before. And when we do that, we get 1 minus V equals, well, the negative distributes, so we get exactly what V was to start with. 1 minus 1 plus 1 minus 1 and so forth, so 1 minus V is equal to V. Add V to both sides, and we get 1 equals 2V, or V equals 1/2.
So now that we have V, let's see what we get when we plug it in. So before we solved that S equals negative 1/6 V, and we just solved that V equals 1/2. So that means S is equal to negative 1/12. Pretty nice proof.
But wait! This proof is so confusing. Can you show me an easier one?
Sure, we can do another proof, and this one uses calculus. This proof needs a whiteboard.
So here's an alternative proof for why R equals 1/4. We start with the Lorentz series, 1 over 1 minus x equals 1 plus x plus x squared plus x cubed and so on. When we take the derivative of both sides, we see that this comes out to be 1 over 1 minus x squared, and this side simplifies to 0 plus 1 plus 2x plus 3x squared, and so on. So when we let x equal negative 1, we get that when we plug in, we get 1 over 4 equals 1 minus 2 plus 3 minus 4, and so on. So in looking at that, we realize that 1/4 is just equal to R. So since R equals 1/4, and S equals negative 1/3 R, S is equal to negative 1/12. So there's another proof involving calculus.
So this concludes our two proofs for why the sum of all positive integers from 1 to infinity equals negative 1/12.
Well, thanks, Professor Pterodactyl. But how is this useful?
This is actually very useful. It's used in physics and forms the basis of some theories in string theory. Pretty interesting.
Yeah,